Hi guys, welcome to 313 part 2, where we're still looking at trigonometry and polar coordinates. So in this section, we're also going to look at some complex numbers. You've heard of complex numbers before. Hopefully they're just imaginary numbers is another way to say that. And so if I have the form a plus bi, we call the a part is the real part, meaning it's just a real number, and then the bi is the imaginary part, okay? So it has kind of two components to it. And you may have not seen this part before. We can actually plot these on what we call a complex plane. So notice that what we normally have as the x-axis is the real axis, so that's where the a component will go. And then what we normally have as the y-axis is where the imaginary part will go. So it might help you if you're writing these out to think about them just like x's and y's. 3 is the real, that'll go x-axis, 4 is the imaginary, that will go on the y. And then you would plot just like you normally would. So like this up here would be point A. 0 plus 2i would correspond to the point 0, 2 if we're thinking about it like that. B, and then we'll do one more, negative 2, 3. So again, it's just a different way of kind of plotting these points, of thinking about them as a real component versus an imaginary component. All right. So this will be very important when we get to vectors next unit as well. So when we talk about, okay, for example, the point A, we can also find its magnitude, which is just essentially the distance from the origin to that point, okay? And we're going to do that just like you think. A lot of times you'll hear this as the modulus. It's the square root of a squared plus b squared. And that should make sense in your brain because this would be a, this would be b, and it's just Pythagorean theorem, okay? To find the angle of this, well, just like we did with polar coordinates, tangent inverse of b over a, because we know this is opposite and this is adjacent, okay? And we always want to think about which quadrant I'm in. So let's go ahead and just look at a couple examples, okay? So it says first graph, and we'll graph it first, negative 5 plus 12i. So this would be like negative 5, 12. So it'd be negative 5 and 12. All right, and I want to find the modulus of that, which is just going to be by using Pythagorean theorem. It's a 5, 12, 13, so my modulus is going to be 13, which is just the distance from the origin to that point. All right, to find theta, we're going to do tangent inverse of 12 over negative 5. Make sure that you're in radian mode when you do this, because everything is in radians. So second, tangent inverse 12 over negative 5. Now, your calculator knows the restrictions for tangent inverse, so it's going to give you something in quadrant either 1 or 4, because remember the restrictions for tangent are from negative pi over 2 to pi over 2. However, I noticed that this coordinate is not in quadrant 4. It is in quadrant 2. So if you remember from what we did before, if I'm in quadrant 4, if it gives me, but I want to get directly across, that's half a circle. So how am I going to get that? I need to add half a circle, which a full circle is 2 pi, so half a circle is pi. So I'm going to take that and add pi, and I get 1.966 radians. So that is the measure of that angle. It's not pretty because it's not an angle on the unit circle that I know, but I can still find it. All right, next example is one that's a little bit easier because you don't have to draw the triangle. Negative 7i would be just on the imaginary axis. The modulus, remember, is the distance from the origin to that point. So that's just going to be 7. That's always positive. It's absolute value. And then theta, well, I could do tangent inverse, but also I could just think about what angle do I know is at the bottom of my circle, and that's just going to be 3 pi over 2. Okay. All right, now we're going to look at something that looks kind of scary, I'll be honest, but it's actually not too bad. So it's called the polar form of a complex number. So we know if I have something like this, and I have A, B, this is theta, and this is R, my radius, okay? So hopefully you know that cosine is adjacent over hypotenuse, so that would be B over R, okay? So adjacent over hypotenuse, ignore that, A over R, okay? So then if I multiply both sides by r, I get r cosine of theta will equal my a component. Sine of theta is adjacent over hypotenuse, so by the same idea, r sine of theta will equal my b component. So the polar form of this, if I just substitute in, okay, instead of a, I'll use r cosine theta, and instead of b, I'll use r sine theta. Again, all I did was kind of use my right triangles and then just kind of manipulated and plugged in. Okay, so let's look at some examples of this. Again, it'll look a little bit scarier than it actually is. So it says to write it in polar form. This is my polar form, so this is what my final answer should look like. Okay, so let's go ahead and kind of draw it out. My real component is square root of 3. This would be 1. That's my b component. All right, well, if I use Pythagorean theorem, take a second, try and do it yourself, I'll end up with a hypotenuse of 2. So remember, this is in the form a plus bi, so a would be root 3, b would be 1. My r is 2. I did that by getting Pythagorean theorem, or you could recognize those numbers, that cosine would be root 3 over 2, and sine would be 1/2. Well, if cosine of theta equals square root of 3 over 2, well, what angle am I talking about? I'm talking about pi over 6. So if I was going to write this in polar form, okay, I can also, another equivalent form that you'll see a lot is the r factored out, like this, okay? So I'm going to go ahead and write it in that form. So if I have the 2 factored out, it would be cosine of pi over 6 plus I sine of pi over 6. So that's just an equivalent representation. My r out front, cosine of whatever theta is, plus I sine of whatever theta is. Okay, let's do another example. All right, so my a here is square root of 6. My b is negative root 2. So square root of 6, negative square root 2. If you use Pythagorean theorem here, you end up with square root of 8, which simplifies to 2 root 2. Okay, so to find tangent, or to find theta, I'm going to use tangent inverse negative square root 2 over square root of 6, which is equivalent to negative 1 over square root of 3. Okay, so if we're thinking about this right here, that's going to be the angle. It's actually not drawn very much to scale, but it's going to have the big X and the little y, so that's going to be at 11 pi over 6. Okay, remember, you could always try both, see which one works. So to write this out in polar form, it's going to look like 2 root 2 cosine of 11 pi over 6 plus I sine of 11 pi over 6. And that's what that'll look like. Now, we can also go backwards. Let's do one example of this. This is in polar form right here. Well, to get it to rectangular form, or you'll hear it as standard form, these mean the exact same thing. I'm just going to distribute and simplify. Cosine of 3 pi over 4 is negative root 2 over 2 plus, I forgot my 5. Don't forget to distribute the 5. Oh my goodness, I'm a disaster. Okay. Sine of, so I distributed the 5, and then sine of 3 pi over 4 is root 2 over 2. So when I simplify this, I get negative 5 root 2 over 2 plus 5 root 2 over 2 I. So my A would be this piece right here, and my B would be that piece right there. Okay. So now let's talk about if I was going to try and like multiply a few of these things together. Okay. So there's kind of an easy way to do this. You could try and like make a box and multiply out, but there's kind of some shortcuts here. So if I was going to multiply two complex numbers, then I multiply the r values and I add the theta values. Okay. If I was going to divide, same idea. I divide the r values and I subtract the theta values. Okay. So let's do this right here. Okay. Multiply, leave your answer in polar form. So I multiply the two r values and then I add the angles. So pi over 3 plus pi over 4. I do want to go ahead and simplify this. Okay. So pi over 3 plus pi over 4, we'll think that's 4 pi over 12 plus 3 pi over 12, which is 7 pi over 12. if you wanted to actually find out what this cosine of 7 pi over 12 was, let's say if you wanted it in standard form, you would have to use your cosine sum identities. And that's your final answer because it says leave it in polar form. So I'm just leaving it exactly like that. All right, let's do one with dividing. Remember, we divide the r values. 2 6 simplifies to 1/3. And then I subtract the angle measures. Okay, well, this really would be 6/16. So if I subtracted that, I would get 3/16. This in here. It'll look something like that. Again, this would be one that even if, off the top of my head, I don't know that you would be able to do this with cosine sum identities. Definitely not with these two because they're not in the unit circle. But there might be a way if there's, if I'm just not thinking of those angles that would add to that, okay, or subtract to that. All right, so then we have one other, which is called de Moivre's theorem, okay? And so essentially what this says is we did multiplying, we did dividing. Well, what if I raise to a power? So if I have some number raised to a power, okay? Well, that's equivalent to taking the r value, raising it to that power, and then multiplying the angles by that, okay? So let's look at what that would look like. And we want this one in standard form, a plus bi. So I'm not leaving it in polar form. I am going to actually evaluate. So I'm going to take my r value and raise it to the power, 4. And then it's going to be cosine of 4 times pi over 12, because I'm taking whatever this number is and multiplying it by that angle. Same thing with sine. Don't forget your I. Well, 4 pi over 12, well, let's start with 2 to the 4th. That's 16. 4 pi over 12 is really just pi over 3. Okay. Well, cosine of pi over 3 is 1/2. Again, if I just wanted it in polar form, this would be your final answer. But it asks for it in standard form, a plus bi. All right, and then this piece would be root 3 over 2. And then I would just distribute the 16. So I get 8 plus 16 divided by 2 is also 8. 8 square root of 3, I. And you could put that I in the front if you'd rather do that. But that's a plus bi form. Okay? So that wraps up kind of some complex numbers. There's lots of different kind of tips and tricks to be able to multiply and divide, but really it's all the same things that we've been doing. Can we find the angle measure? Can we find the r, the distance from the origin, and all of those sorts of things? So that wraps up 313. Have a great rest of your day.